10.3 Physical properties of carboxylic acid. First, we look at physical properties of carboxylic acid in boiling points. In general, carboxylic acid has the strongest boiling point compared to alcohol and amide and also carbonyl as well as the alkenes. The boiling point of carboxylic acid is higher than an alcohol, a ketone, or an aldehyde with the similar molar mass because first, it exists as stable dimers that can form hydrogen bond. And secondly, because molecules in dimers are arranged closely packed, therefore, the hydrogen bonds are relatively strong. What happens? The highest energy is needed to overcome the intermolecular forces and boiling point of carboxylic acid will become high. Now we look at the second physical properties of carboxylic acid, which is solubility in water. Carboxylic acids are soluble in water due to the formation of hydrogen bond between the water molecules and carboxylic acid molecules. Look at how the hydrogen bond is formed with the carboxylic acid and water molecules. And then aliphatic carboxylic acid with carbon which is less or equal than 5 are soluble in water because decrease in molecular weight or size which will have smaller surface area, and what happen, it will have the smaller hydrophobic area. Compared to the aliphatic carboxylic acid, aromatic carboxylic acid are slightly soluble in water due to the huge benzene ring. Dicarboxylic acids are relatively more soluble in water since more hydrogen bonds are formed. Look at how the comparison between the carboxylic acid in terms of solubility. In this structure, it shows that structure of C has the highest solubility compared to A, D, and B. Next, we're going to look at the acidity of carboxylic acid. The arrangement of the strength of acidity, carboxylic acid has the highest acidity compared to phenol, water, and alcohol. One of the reasons because carboxylic acid has higher dissociation in water to form hydroxonium compared to phenol and alcohol. The strength of acidity for carboxylic acid is influenced by two factors. The first one is resonance effect, another one is inductive effect. Now, we look at the acidity of carboxylic acid due to the resonance effect. Carboxylic acids are more acidic due to the resonance stabilization of the carboxylate ion compared to phenol, which can form phenoxide ion, which is less stable. The electron in carboxylate ion are delocalized between more electronegative two oxygen atoms, whereas in phenoxide ion in phenol, the electrons are delocalized in less electronegative carbon atom in benzene ring. So that is why alcohol is less acidic, because negative charge on the oxygen of alkoxide ion are localized on one oxygen atom. Now, we look at the second factors of acidity for carboxylic acid, which is inductive effect. There are electron withdrawing group, in this case is C double bond O, and electron donating group, which is R, known as alkyl group. Carboxylic acid is the most acidic than phenol due to the inductive effect of electron withdrawing group. C double bond O group will reduce the electron density of OH. Therefore, the OH bonds becomes weaker. Thus, proton or H plus is easily donated. Alcohol is the least acidic due to the inductive effect of electron donating group, alkyl group. Alkyl group will increase the electron density of OH. Therefore, the OH bonds become stronger, and what will happen? Proton or H plus is hardly donated. Now, we look at the acidity of halogenated carboxylic acid. Inductive effect of an electron withdrawing group that attached to the carboxylate ion will delocalize the negative charge, thereby stabilize the carboxylate ion and increase acidity. The strength of acidity for halogenated carboxylic acid is influenced by two factors. The first one is number of halogens, and the second one is position of halogens. The number of halogens, electron withdrawing group in the compound, the greater the number of halogens, the electron density of OH will reduce. Thus, the OH bonds become weaker and proton or H plus can be easily released. The compound is said to be more acidic. So if you look at here, the carboxylic acid, which has two Cl group, is more acidic compared to the carboxylic acid, which has only one Cl group. The position of halogens in the compound will also affect the acidity of carboxylic acid. The nearer the distance between halogens and carboxyl group, the electron density of OH will reduce. Thus, the OH bond become weaker and H plus can be easily released. The compound is said to be more acidic. Look at here. Bromine in the first structure has the higher acidity compared to the second structure because the distance the first structure of Br between with the C double bond O group is closer compared to the second structure.